Welcome to the DIY Honda Garage channel. In the Honda HR-V from 2016 to 2022, the diagnostic trouble code DTC P0123 indicates a high voltage issue within the throttle position TP sensor A circuit. This component is critical for the vehicle's engine control module, ECM, as it measures the angle of the throttle valve, providing essential data for fuel management and emissions control. When the voltage exceeds the normal range, it signifies potential faults, such as poor connections or a failing throttle body. The PGM-FI, Programmed Fuel Injection System, relies on accurate sensor readings. Hence, this error can lead to drivability issues, fluctuating RPMs, and increased emissions. Understanding its components and functions is vital for effective troubleshooting. The Throttle Position Sensor A is a crucial sensor located within the throttle body, which is typically situated between the air intake and the intake manifold. Its primary role is to monitor the position of the throttle valve, sending this data to the engine control module, ECM, to adjust the air-fuel mixture accordingly. A consistent and accurate signal is vital for maintaining optimal engine performance, fuel efficiency, and emission standards. If this sensor malfunctions, leading to a high voltage signal, the ECM can misinterpret the throttle position, which can result in poor vehicle performance and potential damage over time. The location of the throttle body is important, as accessing it is a critical step during the troubleshooting process for this DTC. When diagnosing DTC P0123, several potential causes must be evaluated. Firstly, the throttle position sensor A itself could be faulty, leading to an inaccurate voltage reading. Moreover, poor connections at the throttle body or loose terminals at the powertrain control module, PCM, can disrupt the signal flow, making it appear as high voltage. Open circuits in the wiring connecting these components can also cause this issue. Thus, physically inspecting the wires for damage or breaks is essential. In some cases, an outdated PCM software version may also contribute to this problem, as it could fail to interpret the signals correctly. Thoroughly addressing these areas will help identify the root cause of the DTC. The symptoms of DTC P0123 can significantly impact the driving experience. Drivers may notice engine performance issues, leading to hesitations or stalling. Fluctuating RPMs can also occur, affecting the vehicle's responsiveness when accelerating or decelerating. Additionally, increased emissions may result from the incorrect air-fuel mixture caused by the faulty throttle position signal. In many cases, the check engine light will illuminate on the dashboard, signaling a need for diagnostic review. Lastly, a loss of throttle response may manifest, making it difficult for the driver to accelerate effectively, posing a safety risk. Recognizing these symptoms early is essential for timely repairs and maintenance. Begin troubleshooting DTC P0123 by first ensuring the vehicle is in the on mode, which powers the electrical systems, including the PGM-FI. Utilize the Honda Diagnostic System, HDS, to clear the DTC to observe whether it reappears. Following this, check the signal parameters of the TP sensor A with the HDS. Specifically, confirm if the voltage exceeds 4.8 volts. If the values do match, this indicates that the failure has been duplicated, allowing the technician to proceed with further diagnosis. If not, consider that the system may be intermittently failing. Hence, check for potential loose connections or malfunctioning terminals at both the throttle body and the PCM. Detailed attention to these components is crucial for accurately diagnosing the problem. In this step, the technician needs to check for any pending or confirmed DTCs using the HDS. Specifically, assess if DTC P0223 which relates to the throttle position sensor B circuit, is also present. If both P0123 and P0223 are indicated simultaneously, this suggests a common fault in the throttle control system, warranting further investigation focused on shared components, such as wiring and connectors. If only P0123 is present, the technician should continue diagnosing in the next step. This systematic approach ensures that all potential underlying issues are addressed effectively without overlooking interconnected faults. For this step, first, turn the vehicle to off mode to ensure safety during diagnostics. Next, disconnect the 6-pin throttle body connector. Following this, the vehicle should be switched back to on mode, and a measurement of voltage must be taken between specified test points. These points are found within the throttle body connector and the body ground. Ideally, the voltage should be around 5.0 volts. This reading indicates the integrity of the circuit from the PCM to the throttle body. If the voltage is adequate, it suggests that the throttle body itself may need replacing, as it is likely the source of the high voltage error. Should the voltage be incorrect, further investigation is necessary. In this troubleshooting step, begin by ensuring the vehicle is turned off for safety. Jump the SCS service check signal line using the HDS, which allows access to the diagnostic circuits needed for further testing. Disconnect the PCM connector C51P to isolate the circuits appropriately. With the throttle body connector disconnected, check the continuity between the specified test points. This will confirm if the THL1 wire is intact, which transmits signals between the throttle body and the PCM. Continuity should be present. If not, the technician must repair any open circuits found in the wiring between the PCM and throttle body. This precise checking ensures that all electrical pathways are operational and without faults. For the fifth step in diagnosing DTC P0123, start by turning the vehicle back to the off mode for safety. Repeat jumping the SCS line to access the necessary diagnostic signals. Next, disconnect the PCM connector C51P and the throttle body 6P connector to perform a thorough inspection. Measure the continuity between the specified test points to ascertain the operational status of the SG3 line. It is crucial that continuity is present. If found, this would suggest the wiring is intact, and the issue may lie within the PCM itself or its software version. If continuity is absent, repair any breaks in the wiring between the PCM and throttle body to restore circuitry integrity, optimizing functional communication. Upon completing all necessary repairs related to DTC P0123, it is crucial to perform final verification steps. Start by ensuring that the DTC has been cleared successfully using the HDS. After clearing, retest the system to confirm that the throttle position sensor A is functioning within the expected parameters. A thorough test drive is essential. This allows the technician to observe real-world performance, ensuring that there are no further drivability issues or CEL, check engine light activation. If all outcomes are positive, it indicates that the repairs were successful, resolving the underlying fault and restoring the vehicle's performance to its designed specifications. To prevent the recurrence of issues related to DTC P0123, implementing preventive maintenance is key. Regularly inspecting the wiring connected to the throttle body and PCM can help catch potential wear or damage before a fault occurs. Ensuring that all electrical connections are tight and free of corrosion contributes significantly to system reliability. Furthermore, scheduled updates to the PCM software can improve vehicle performance by addressing possible bugs and improving data accuracy. Taking these proactive measures is beneficial not only for avoiding future DTCs, but also for the overall longevity and efficiency of the Honda HR-V's engine management system. In conclusion, DTC P0123 signifies a high voltage issue in the throttle position sensor A circuit, which can have significant implications for the vehicle's overall performance. A structured approach to diagnostics is essential, ensuring that all potential causes are explored, from sensor failures to wiring and connectivity issues. Recognizing symptoms early can aid in timely repairs, maintaining the vehicle's reliability. Preventive maintenance practices, such as regular inspections and updating software, can help mitigate future occurrences of similar DTCs. Adhering to these diagnostic and preventive measures will ensure optimal functionality of the Honda HR-V, safeguarding the driving experience. Please like and subscribe to the channel. See you next time.